Welcome everybody, I am Balaji from CDAC Electronicity Bangalore. I will be giving you a gentle introduction to the intricacies involved in the PKI technology. This technology is activated through an infrastructure consisting of many components relating to the trust. I will be covering the technical process involved in digitally signing a document, followed by the verification process of a digitally signed document, the role of the certifying authorities in issuing you a digital signature certificate, which you can use it for digital signing, will be exemplified. We will also be seeing how trust can be established, and specifically we will be emphasizing on the hierarchical trust model which is being adopted in our country.
So now let's start the session, the public key infrastructure components. So now let us try to understand what is a digital signature. In the paper-based world, a physical signature is basically tied to a person. Let us take a paper-based document. A person puts his signature, and below it you can see the name of the person who has signed it. And usually it is only that person, that particular style of putting up the signature belongs to that particular person. So that is the kind of confidence that you get over the document, over the physical signature. Similarly, can you get such kind of confidence in an electronic document? The answer is yes, and it's even more stronger and better in the digital world. The thing is, a digital signature of a message is basically a number which is dependent on some secret known only to the signer. And the second point is, it's additionally tied to the content of the message that is being signed. This is the most significant difference from the digital world and the non-digital world. So in the paper-based world, the content is not tied to the signature. Whatever is written on the top of it, it is basically assumed that one person signs it, he is agreeing to the content which is being written on top of, above it. So, but there can be a possibility that someone can do some changes to the content, can do some small minor changes also on the content. But such kind of thing can never happen in this electronic world where digital signatures are used. Because if such a thing has been done, immediately that signature becomes invalidated and the content becomes the document or the content becomes an unsigned one. So that is the beauty of this digital signature. So let me restate the two key features of a digital signature. Basically, for affixing a digital signature in a document, one requires a secret which is known only to the signer, and basically this will be a mathematical number which is known to only the signer. And also the signature of a message is tied to the content which is being signed. So these are the 2 points that one should be remembering. Signatures must be verifiable. Like you have a paper-based signature, you can ask me this: how do you verify a paper-based signature? You ask a person to sign a document, and then you ask the person to re-sign it some other place, and then you cross-verify whether both are looking alike by using some experts who are proficient in finding out the differences, in minor differences that may exist in a signature to signature in one's handwriting. So similarly, in the digital world or electronic world also, one should be able to verify a digital signature. So how? That we'll see in the next few slides. And applications of a digital signature are authentication, data integrity, non-repudiation. So how a digital signature is first can be affixed? The first thing is, for an individual, a pair of keys are given. The first one is the public key and another one is the private key. Public key can be given or distributed to everyone, including the person. Private key will be known only to the individual or known only to the owner. So to digitally sign an electronic document, the signer will use his or her private key. This is the most important thing. To digitally sign an electronic document, the signer will be using his or her private key. To verify a digital signature, the verifier will use the signer's public key. Suppose if I want to verify whether this is the person who has put this digital signature, then I have to use that particular person's public key for verification process. So these two things has to be born in the reader's mind. Now let us take an example so that makes things clear. Let us take the case of Viru. Viru has a pair of keys, public key and private key. Private key is securely kept by Viru. He keeps it very safely, he does not give it to anyone. Public key is one thing which he distributes to everyone. Not only his friends, he can distribute to anybody else in this world. Now, this public key is with Pat, Sam and Don. Let us say these three people are having the Viru's public key. Now, this is the thing that one has to understand. The public key is meant for widespread distribution, while private key should be kept privately with the person. So in this case, Viru will keep his private key to himself. Now let us go to the process of digitally signing an electronic document. Let us consider this piece of text. Here there is a small piece of text. How do you sign this? First of all, the first step is you have to create a hash of this text. The hash will produce a message digest which is unique to this particular text. The second step is to encrypt this message digest with the private key. So in the case of Viru, this particular message digest will be encrypted with Viru's private key. The output is what you call as a digital signature. The encrypted message digest with one's private key is called as the digital signature. Step number 3, what you do is you take this digital signature and append to your original piece of document or text. So now the document, digitally signed document, looks something like this in step number 3. Now how do I verify this particular digitally signed document? First of all, I have to only select the content of the particular message which I have received. I have to generate a hash which will give me the message digest. Now I have to take the digital signature separately, and I have to decrypt with the public key of the sender because he is the person who has digitally signed it. So I have to decrypt this particular digital signature by using that particular sender's public key. So in the case of Viru, this has to be decrypted with Viru's public key. So that will give me the message digest. So now the next thing is I have to compare whether these two message digests are equivalent. And if they are equivalent, I do not have any issue, and the information has been really signed by, has come intact. Nobody has changed the content in between, and it has been come intact, has reached me intact. But I will tell you the disadvantages a bit later. Let me graphically illustrate this process. Now let us consider two people, Viru and Jay. And Viru is the sender, Jay is the receiver here. Viru has a piece of text which is to be sent to Jay. Now what he does, the first step he does is he passes the piece of information or the piece of the message to a hash function which generates a message digest. And now Viru encrypts that message digest by using his private key, which is what we call as a signature. This signature is then added to the document and as transmitted to the via a transmission medium, and it reaches the receiver J. So how can J verify this particular signature of Viru? So now J takes the content of the message, he again passes it to the hash function and generates a message digest. Then he takes the signature component of the message, he decrypts it by using Viru's public key and gets the message digest which has been originally sent by Viru. Now if these two message digests are same, then J can be sure that the message has not been changed. So this is the confidence that J gets on that that the message is not changed in the transmission process. But the question is for J is, has really Viru assigned this document, or is it someone who is acting as Viru assigned this document? How can you ensure to J that it is really Viru who has signed this document and not somebody else who is posing as Viru? Such kind of questions may come to your mind. So, but before that, now let me tell you what is the signature creation is. Signature creation is nothing but hashing the message content, and which will produce you a message digest, and which has to be encrypted by a private key, by a sender's private key, which is called as a signature creation. And decryption process, that is, which is the signature verification process, involves taking the encrypted hash and decrypt it, and then you get a message digest. So this is what basically is the signature verification process is. So now I was asking you a question: how can J be certain that it is Viru who has really signed this document and nobody else who has posed as Viru? For that, you need someone to certify that this particular set of key, this particular public key, whatever it means, for this particular public key really belongs to Viru. So the person who certifies that one is called as a certifying authority. And what he does by certifying is, he issues you a digital certificate. The person who is certifying that this is Mr. Viru's public key issues a digital certificate to Mr. Viru. So now let's get back, what does a digital certificate mean? A digital certificate binds the owner's public key, name, email and other necessary information together. So now here let us look at Viru's digital certificate. Viru's digital certificate contains the name Viru, his department, his certificate information, a serial number, his date, the certificate expiration date and the public key of Viru. So this is what a digital certificate contains. And this has been, most importantly, this particular information has been digitally signed by the certifier. Okay, this is again, this particular piece of information is basically signed by the certifier. So once it has been signed by the certifier, it is then called as a digital certificate. So now Viru can always show this digital certificate to anyone, saying that he is the owner of this particular public key. Now let us look at the structure of the digital certificate. The structure is typically in a X.509 format. The version 3 format looks like this. It contains a certificate version, serial number, algorithm, issuer, validity, subject public key information, issuer's unique identifier, subject unique identifier, extensions, certificate signature algorithm and the certificate signature. So this is a real signature certificate, real certificate, how it looks like. Here again you have the certificate, you have a set of data, version number, serial number, signature algorithm, which means that MD5 with RSA encryption has been used for this thing, which has been issued by some ZA, and other information is given, validity information is given, subject is given, and the signature algorithm is given, which means basically and also the public key. Before this, you can also find out the public key of the person to whom it is being issued. Now, the question is, where can I get a digital certificate, or where can Viru get a digital certificate which is acceptable to everyone? So Viru cannot definitely go and get a certificate from his friend, or from his wife, or from somebody else. So you should get it from an authority of repute and who is agreeable to everyone else. So the person to whom, from where he can get a certificate, is basically called as a certifying authority, CA. And CA is an entity which issues digital certificate to various people and various individuals, various organizations, etc. So it is a trusted third party, and CAs are the important characteristics or components of the public key infrastructure. Now, what is the responsibility of the CA? CA has to verify the credentials of the person requesting for the certificate. So, suppose if Viru is requesting for a certificate, it has to really identify whether is it really Mr. Viru who is asking for the certificate, and whether is it the public key which has been claimed to be of Viru's, is that the public key of Mr. Viru, has to be verified by them and certified by them. And finally, after verification process, it can give a certificate to Viru saying that this is Mr. Viru, his public key is so and so, and we approve it. In the sense, they digitally signed it, saying they're putting their name and seal on it. So this is how you issue the CS issue the certificate. They can also revoke the certificate once the period gets expired or due to some other reasons. And once a certificate has been revoked, they can generate. They have to generate and upload it in a certificate revocation list, CRL. So these are the responsibilities of a certifying authority. But can we trust the certifying authority? Suppose, let us say that Viru goes and gets a certificate from a certifying authority. But how can I trust a particular certifying authority? So what are the trust models? How can I establish a trust model for the certifying authority? The received certificate will definitely show that it belongs to Viru. But does it really belong to Viru? I might have my own company as a certifying authority, and I can say that this particular certificate really belongs to Viru, where there is no person called Viru who is in existence. So does it really belong to Viru? You can also generate a certificate with the name Viru and can use it for intercepting emails and carry out man-in-the-middle attacks. One way is to employ a direct trust which is invisible practically. So I can find out, call up Viru and verify whether this is his public key or whether he has sent me a message or not. So that is one way of doing it. But suppose assume that I don't know Viru, then how can I do this? Then probably this model will not work out. So there are a couple of other models which are followed for establishing the trust. One is a subordinate hierarchy, another is a cross-certified mesh, hybrid, bridge, CA, trust list. Let us look at these one by one. First and important is the hierarchical trust. In the hierarchical trust model, there exists something called as a root certifying authority who is at the top of the hierarchy. All the certifying authorities will come below the root certifying authorities, and each participant must have the knowledge of the root certifying authority's public key. This is the trust model which is followed in our country, in India. In this particular model, CCA, Controller of Certifying Authority, has set up the Root Certifying Authority of India, RCI, and they actually act as the Root Certifying Authority. Under the Root Certifying Authority, there are 7 certifying authorities like TCS, ENCODE, 3I, Infotech, etc., NIC, etc. So these certifying authorities issue certificates to individuals, to companies, and to other organizations. Now, I get a certificate issued by one of these certifying authorities, and my friend or someone, I am sending a message to some X by signing that particular message. So now that X, upon receiving the message, wants to know that whether it is really me who has sent that message. So what he can do is, obviously he knows that this is the he decrypts it and finds that this is really come indeed from Balaji. The hierarchical trust model. The hierarchical structure is followed here with a well-known root CA. The root CA will certify its immediate descendants, particularly the certifying authorities, which in turn will certify their descendants. Now each participant should have the knowledge of the root certifying authorities public key, so that he can understand a certificate that has been signed by any of the intermediaries. This is the system which is followed in our country, India. So in India, the controller of certifying authority operates the root certifying authority. Below it, there are the certifying authorities like NIC, TCS, etc., who issue certificates to individuals and organizations and other institutions. The individual certificates are actually signed by the individuals and organizations. Certificates are signed by the certifying authority, and the certificate of the certifying authorities are actually signed by the root certifying authority, that is the CCAs. This is the nodal. Root certifying authority is the central and nodal agency in the country, and which is accepted to have legal validity. So in this hierarchical trust model, a participant can trust a message which has been signed by any of the certifying authority by simply relying on the root certifying authority. The only drawback is that a compromise of the private key of someone in this hierarchy would be disastrous for the security of its entire hierarchy, of the security of its hierarchy below it. So this is the drawback of the subordinate hierarchy. But otherwise, this is the currently followed and adopted model in our country. Cross-certified mesh. This is another model of another way of establishing a trust. Here what happens is, any certifying authority can certify any other certifying authority. So this model can serve well to represent dynamically changing organization structure, but it makes it more difficult to determine whether a particular CA is an appropriate certifier for another certifying authority. So I can operate two sister companies, and both are certifying authorities. One company will certify the another company will certify the another. So such kind of issues can also crop up in a cross-certified mesh. So that is the drawback of this particular trust model. The next one is a hybrid model, which has both hierarchical as well as cross-certification, but at different levels. Let us look into it. Here what happens is, there are multiple root certifying authorities who exist, and all the non-root certifying authorities will be certified within the root certifying authority. Now the root certifying authorities establish cross-certified mesh among themselves, so each hierarchy can reach every other hierarchy via single cross-certificate at the root level. Selective cross-certification between the non-root certifying authorities is also permissible. So let us take an example. As I said earlier, in India, you have the root certifying authority and the various CAs below it. Now, how can I trust a message which has been sent by someone from another country, and who is claiming to whose document, digitally signed document, is being claimed to be certified by some certifying authority. How can I trust that? Because I don't know anything about the country, or I don't know about the certifying authorities in that country, and he says that it is being certified by some xyz.com or whatever it may be. So I am not aware of it. So how do I trust that? So in the hierarchical model, what happens is, the message is, I get a certificate from someone, from a certifying authority who has been approved by the root certifying authority of this country. Similarly, the person X in the other country should have got a certificate from a certifying authority which adopts the hierarchical trust model and gets a certificate from, and the certifying authority actually has got the approval from its root certifying authority. So this has happened at the other side also. Now, the root certifying authorities of these two countries, India and the country X, has to cross-certify each other. So if that happens, then that particular certificate and other documents will get legal sanctity. So the root certifying authorities can establish a cross-certified mesh among themselves. So each hierarchy can reach every other hierarchy via single cross-certificate at the root level. Selective cross-certification is also possible. Root certifying authority of India can selectively cross-certify a handful of nations or a couple of other nations' root certifying authorities, which is also permissible. Now the problem with the hybrid model is it cannot scale to large numbers. So there are 200 countries, there are 200 plus 250 countries in this world. Then you have to cross-certify all the 249 countries. So basically cross-certification grows to n into n minus 1 for n number of hierarchies to be fully connected, which is a very tedious and cumbersome process. Instead of that, you adopt a bridge certifying authority model which has a central cross-certifying authorities. Now, in this model, what happens is, the root certifying authority of a particular nation will accept the signature which has been accepted by a super root certifying authority. So the super root certifying authority can provide cross certificates to all these people, to all the root certifying authorities below it. To make it more clear, let me give a simple example. Let us consider that United Nations sets up the super root certifying authority. Now it can issue certificates to the root certifying authority of India and to other root certifying authorities of various countries. So now whoever is tied up with UN, those documents can be easily verified and can even get a legal sanctity in the different parts of the country. So this is possible. This is a possibility. So this model, bridge certifying authority model, therefore appears to be the prime candidate to extend PKI across a large number of organizations and nations. Another simple model is something of a trust list. So in this model, all the clients or the individuals will maintain a set of trusted roots. So to be validated, the certificate must chain to one of these trusted roots, sometimes directly and without intervening the certifying authorities. Endpoints are required to be configured with large set of public keys if communication with large number of certifying authorities is to be supposed. For example, as an individual capacity, I maintain a set of people, I maintain a set of certifying authorities whom I trust. So, when someone sends a message which has been digitally signed, and if the signature and when I verify it and find the certifier, the person who has sent me has got a digital certificate from one of the trusted sources, I usually take it as such. But suppose if it comes from somebody else whom I don't know, but that particular certifying authority comes below one of the trusted member list here in my mind, then I agreed that particular certification. So let me clarify it with an example. So let us consider person X. X has obtained a certificate from a certifying authority, which I don't know. Now, the certifying authority obviously comes somewhere in a list who has been certified, has been issued. The certifying authority has been issued a certificate by another certifying authority whom I trust and is maintained in my trust list. So obviously I trust the person X. So this is a very fairly easy and straightforward model to understand, but the only problem is that the client has to have the knowledge of all the public keys, and he has to trust all the people to have the communication to be supported. So that may not be a feasible approach, though it is a easy and fairly straightforward model. As I said, in our country, in India, the hierarchical trust model is followed. The other models are just for our academic relevance. The next is about a certification validation method. How do you validate a certificate? Sometimes before we saw the validation of a digital signature. Right now we are talking about validation of the certificate which has been issued by a certifying authority. Obviously, validating a certificate requires the certificate validation logic to perform a series of checks. The digital signature, the trust, the time the certificate has been issued, whether it is there in the revocation list, what is the format. These are the process which has to be followed. Next, let us talk about key management. Here in the process of signing, a user needs a pair of keys. One is the private key and another is the public key. The public key can be distributed to anyone, while the private key has to be kept securely with the user. So key management deals with all the provisions made in the crypto system designed to deal with the keys. So what is the process of generating the keys? How to exchange them? How to distribute them? How to store them? Safeguard them? Use them? How a central authority can approve that this is the key which has been used for signing? How to replace them? Etc. Similarly, there exists a life cycle for a digital certificate. A digital certificate can be used till the renewal period. Typically, a certificate is valid for 2 years, or it can be used till a rekeying request comes, or it can be used until it is revoked. So these are the three possibilities before which a digital certificate can be legally used. So using it until renewal. A digital certificate issued to a user has a defined validity period, typically 2 years. So if Viru wants to renew his expiring certificate, he must send a renewal request to his certifying authority and digitally sign his old certificate. The certifying authority will issue a new certificate with a new validity period. If there is an overlap in the validity period, CA can place the old certificate in his certificate revocation list. So this is how the process happens. We are not talking about the key changes here. We are only talking about the certification here. A person, how he applies and gets a new certificate. Now, suppose J feels that his public and private key pairs are not lucky to him and he wants to change them, or he feels that it has been compromised, or he wants to get rid of them and get a new pair of keys. So what he has to do? He has to generate a new key pair. Then he creates a rekey request including his new public key, which is digitally signed by using his old private key and sends his request to the certifying authority. Here you have to note one point. It's only the person or the individual or the organization which generates the keys on their side and sends only the public key to the certifying authority along with other documentation and identification information. So then the certifying authority verifies their identity and accepts their public key and signs them by issuing a certificate. So in the case of rekey request, what happens is a person has to create a new pair of keys and then use his new public key and ask for a rekey certificate by digitally signing using his old private key and sends a request to the certified authority. The certifying authority will create a new certificate with a new public key and adds the old certificate to the certificate revocation list. So in this case, what happens is the existing certificate has to be replaced because the keys are changed. Because the certificate contains a person's public key, so you are changing the public key, so the certification also has to be changed. The certificate also has to be changed. So a new certificate is created with a new public key and which is added, and the old certificate which has been used by Jay so far will be added to the certificate revocation list, which is a list which contains those certificates which has been revoked. Now a certificate can be used till revocation. So Viru's private key has been compromised. So before someone uses his key pretending to be Viru, he wants to revoke his certificate. So what he does, he generates a new key pair and sends the public key to the certifying authority and obtains a new certificate. CA adds the old certificate to the CRM. So suppose Viru's private key has been compromised, he generates a new key pair and immediately sends the public key to the certifying authority and obtains a new certificate. So immediately the certifying authority has to keep his old certificate in the certificate revocation list. So this is the process which is used by the certifying authority and when someone requests for a revocation. So these are the references from which some of the references which would help you to learn more about the topics covered in the session. Thank you.
With this, I would like to conclude this session. We saw the process behind the digital signing of a document. We also learned about the role of the certifying authority in not only issuing you the digital signature certificate, but also the need in hierarchical trust model. Thank you for your kind attention.